Hi everyone. How's everything going so far? All right. This will be the first workshop of developer student clubs, Python fundamentals, and it's gonna be hosted by Michael. Mike, I'm gonna pass the mic for you.
Awesome. Thank you. It's 2:02. Plan to start at 2. I think it's a good time to start. I'd rather be early than sorry. So again, like Alexis said earlier, this is Python for the real world. So the goals of this course really was a hackathon crash course. We will cover a lot of things pretty fast, and the main goal that I really wanted to was get to the crux of what's important and the skills that you want to take away in order to code well for a hackathon, which is, for those of you who don't know, a hackathon is a 24-hour event hosted by sponsors where you build a product based on some theme and present it to them after the 24 hours. It's really fun. Unfortunately, to the virus, a lot of hackathons have been moved to virtual, which is okay, but I think in spirit of the hackathon event, it's not the same. Hopefully things go back to normal next year and we will still have the same kind of idea. So again, I really want to emphasize on teaching you Python in order to solve problems rather than teaching you these esoteric properties and meta theories that really aren't necessary in order to get you up and going. Who I am, what I'm here for. My name's Michael Pressman, or just call me Mike. I'm a student at York University, as well as an aspiring software engineer. I've been coding Python for around 2, 3, maybe 3.5 years now, and I've been coding Flask, which is the backend web development framework, one of many that Python offers, for around 2 years. The Flask portion of this course will come next, which will be following this. Again, this is just the fundamentals in order to get the ball rolling. So then I can teach you Flask with a comfortable understanding that you guys have the fundamentals and knowledge in order to go into the course being confident with what I'm teaching, because that one will be a little bit more fast paced and will require assumption of what you know. I'm a Python fanboy, which is interesting because I started off with Python as well as Java kind of side by side maybe 4 years ago. And I kind of always neglected Python because of its lack of expressiveness, which is something you'll see later on. But after you get in, you dive more deeply into other programming languages like Java, C Sharp, C++, C, you kind of miss the simplicity of Python, which is just to solve a problem, right? It may look kind of not fun, may look kind of ugly at sometimes, but that's really not its goal. Its goal is to solve a problem, which is what I really like about it. Again, as I said, the goal of this course is to teach you the foundations of Python, what we will need for the next course, which will be backend Flask development, where we will be doing more serious web development, more hands-on stuff. Um, yeah, that's not me in the picture, of course. Maybe I'll look handsome like that one day, but I think you can see me all on the camera. I hope so. If you ever want to contact me, feel free. I'll make these slides available after the course ends, as well as I should actually, I don't know if we're recording this, but are we recording this, Alexis?
Yes, it is recorded.
Okay, so it's recorded. So awesome. You can go
Mhm.
back and watch this, and feel free to contact me in any one of my platforms. I have a GitHub where I post most of my project repositories, if not all. LinkedIn as well, and you can just feel free to shoot me an email anytime. I'd be happy to talk to you. Again, the goals of this course is lay a foundation for Python development, get ready for part 2 of this series, which I promise you will be much more interesting than this one. This one may seem slow at times, may seem uninteresting, but I really want you to focus, and I did my best to cut only the meat out of Python in order to keep you engaged in what's important and get you hackathon ready. Sometimes maybe you won't even be writing Flask backend. You won't be writing backend websites with big databases, big object relational maps, but you might need Python to solve other problems. And I'll show you an example at the end of this, how we can use Python really simply to solve other problems, as I've done in the past. Recently, I had a fourth year senior who was from Southern California approach me and asked me to help him write a script to apply for jobs. There was a job board that his school offered, and he needed to write a script where he could take all of the emails, parse them, save them in a text file, and automatically send a generated generic email to those companies. And me and him worked together and were able to do that in the night. So that's another example of problems that Python can solve simply without getting into deeply rooted issues and confusions and design paradigms that other languages like Java and C and C++ have by nature. I also want to talk about what this workshop isn't. I'm not going to teach you fundamental programming. I'm not going to teach you how to use expressions, how to use statements, what paradigms exist. I kind of want to skip all that. Maybe I'll do that in the future. I'll make a course. Either I'll do it again through the Google Developer Clubs, or I'll just post it on YouTube. But the assumption of this course is that you have a basic understanding of programming, which is completed York's EECS 1012 or equivalent, which is just basic understanding of how if statements work, control flow, loops, and types. Um, Again, this workshop may seem elementary, but please note that this basic Python is required as a foundation for backend Flask, like I've stressed earlier. You've got to know what a theorem is before you learn how to prove one, right? Proving stuff by contrapositives, contradictions may seem interesting, but if you don't understand the whole notion of a theorem beforehand, it's just all nonsense. So on the left-hand side, I wrote a file transfer protocol tool for the web. Which is a fancy way of saying I wrote root access to my computer at home through a website. There would be times where I would be at school and I had a project that I would write on my desktop computer, but I only brought my MacBook, of course, my laptop rather, to class, and I would forget an assignment on my home PC. And this would be a problem because, absolutely, I will share the slides after. I actually, you know what? Maybe I'll do that right quickly. If you guys, hold on, let's actually, I feel like it's more fair if I upload the slides now. It'll take a couple seconds. All right, anyways, I'm going to continue while that is happening. Hopefully everything is still continued. Yeah, everything is still being, this is being shared. And there's a link to the slides. Two monitors can be a pain more than a pleasure. The recording will be posted later. Don't worry, you'll get access to that. Again, as I was saying, there would be times where I would be in school and I would have files at my home PC, and unfortunately, there'd be trouble because I couldn't access it unless I went all the way home, which was like an hour commute. So I wrote a tool which would port forward the root C drive on my home PC such that I could connect via HTTP and get access to all my files and folders at home. So as you can see, I have my directory here. I'd have /home/user/bin and all those files, and you could click through the files, find any files you want, and download them. As long as you have root access as admin, all the security permissions are there, and that was a really nice, comfortable tool because I thought, you know what, I can write projects at home, forget to download them, and then I'll be at school and download them through the web. And all that required was a little bit of port forwarding and a little bit of socket knowledge. Another project I wrote was for my mom's business where she runs a musical theater company, and a lot of the times she has sales, ticket sales, and she would do this old-fashioned way where she would just sell them by hand. So I decided to set up a database and based website such that people would buy the tickets online. They would get the required seats according to what they desired, and then they'd get an email with their seats and a QR code. So when they would come to the door, they would just scan the QR code. The attendee at the door would see, okay, you are sitting in row 9, seat A, and they would be seated there, as you can see in the second image. And of course, there'd be all this information such as, is this seat filled? Yes. Who is this seat filled by? Of course, it's just only me because this wasn't a production database, it was just development. And so we ended up doing it that way, and it was really nice and comfortable. We also had seats scanned, whether they would actually attend the show or not, and when they did have their seat, when they did have their scanned card come in. Anyways, let's continue. It's still being shared. I can never. Okay. This is an example of what we don't want to end up with. This is eClass, Yorku's website. Wasn't a atrocity for, I'm pretty sure most of you know, for the first 2 weeks. A lot of ended up failures, a lot of 404 redirects, a lot of nonsense, which caused a lot of headache for everybody. And I don't want that. And doing some digging, I kind of understood why. I kind of understood the problems, and hopefully we can avoid that. And this was a funny error I got one day while trying to get in. There's a couple ways to set up. I don't want you to read this too detailed right now. The slides are shared. This will be recorded, so I want you to go after in your own time and look at this, but don't do this right now. The Python that we'll be using, so there's Python 2, which comes default on Mac and Linux, but today everyone is using Python 3 and up. I personally use Python 3.8 at the very least. There's also a package manager. So a lot of the times the things that you'll be coded, or rather will be coding, have already been written by someone who has taken the time to write it as a library and packages it as a library which you can download. Pip is this package manager that allows you to seamlessly download those libraries and integrate it into your project. Right? It's the notion of don't reinvent the wheel if it's already there. If there's already a functionality that you know that exists and is supported well, download it, set it up, and have it run in while integrating with your own project. In part 2 of this series, I'll go over how to use pip properly and how to set it up much better. There's also a virtual environment which I recommend using. So a lot of the times when you download Python and download these libraries via pip, they'll scatter everywhere on your computer, right? You'll have one version of library XYZ sit here, another version sit here, and there will be a lot of collusion and a mess, essentially. A virtual environment allows you to set up a kind of container of Python that lives in one folder. So you set up a virtual environment, have it run, and effectively the virtual environment only lives as long as you let it live. All the versions of a library will live in that one folder, and if there's any problems, you can go ahead and delete it. So at the end of the day, if you ended up stop liking Python or just stopped using it, instead of going through each and every file in your directory to delete the dependencies, you would just download this one containerized folder, which would contain everything in there. Uh, uh, Windows and Mac, I just here kind of go over how to download it and set it up in your own time. Uh, Basically, Python is a interpreted programming language versus a compiled programming language such as Java and C++ or C or C Sharp. Interpreted means that it gets the language and gets interpreted at runtime. So there is no beforehand compilation where it checks for linting errors or computation errors, but the errors kind of all appear at runtime. Now this can be a blessing and a curse because it gets run faster at immediate times, but this is also a curse because the errors are kind of harder to catch, right? There is no compiler to give you warnings like this library will not support this version or that. It's kind of up to your own mandate to make sure that you have set up everything and wrote everything perfectly and caught all errors, or rather potential errors, in the right way. Here's another example, is a continuation of the last slides of setting up virtual environment. Don't get too finicky again on this right now, because it is kind of a headache. I do provide instructions on Windows, Mac, and Linux, and I tried all of these for Windows, Mac, and Linux. I do use Windows 10 on a daily basis. I also have a MacBook. I don't use now, but I still have one, and I use Linux also as well. Unfortunately, not as much as Windows 10. That's because of other reasons, because my video card doesn't support it. But nevertheless, I have made sure that these instructions will run on every system. So whatever you have, it'll work. But for now, I also wanted to mention that it's hard setting up the first time, right? It took me a while. And also, the system you use can kind of depend on how easy or hard it is, depending on what version you have, right? For me, Windows and Mac was the easiest when I was going through this before presenting this to you, which is funny because usually the community boasts Linux and saying that Linux will be the easiest, but it took me actually a little bit of Googling to figure out what small fix was required to get it set up. But nevertheless, I got it up and running, which is kind of the main point, that you'll get it running regardless. So if you struggle, don't fret, don't give up, keep trying, keep Googling, message me, and we'll make sure it works. For now, I want you to, not right now, I don't want you to do this right now. I'd rather you follow the slides and follow my functional thinking. But there is online Python interpreter, which basically means that you can go on this website, code Python, hit run, execute, and it'll execute it. So the interpreter technically lives on this website's server. So when you hit run, it sends the whole code that you wrote to the server, which then runs it on the server and sends the request, sends your response back. So there's no setting up. Rather than going to, all it requires is going to the web, going to this website, and coding in there. This is what I use to present all of the continuing slides. All the screenshots are from this website, just to show you that everything works there. There's also many alternatives to this. This isn't the only website that does this. And although it says online compiler, again, remember Python is an interpreted language, not a compiled language. Now I want to go over Python as a whole. When to use Python, when to use it. So Python is great, in my opinion. Again, take this with a grain of salt for prototyping, quick problem solving, and mathematics, right? Again, Python will solve a problem quickly and efficiently, but it will not solve heavy computational problems as quickly, right? If you have a lot of math or a lot of computational tasks that are CPU bound, Python might not be the best. And again, that comes down to the fact that it's not compiled, right? The CPU doesn't take care of those instructions beforehand, but they're taken care of during time. Python is also weakly typed. In Java, you'll see things like int, var, int x equals 5, right? And the int at the beginning means that the value, the variable x has the primitive type of integer. Python doesn't need that. You can just say x equals 5. Python will interpret that, oh, that's an integer type, and will continue from there. So there's no need to kind of bound the types beforehand. Python will interpret it before. Again, that's kind of a benefit that you get from Python, which comes with a cost. There's never no trade-off. And the cost is that this will sometimes cause type cohesion problems. This will sometimes cause problems with interpreting other people's code as to what they try to implement versus what you understand, and can also be CPU bound issues and runtime issues and speed issues, which is not what Python is for. Oh, camera fell. Python is not for, in my opinion, fast running tasks. It is used to write something quickly, but not to solve a problem that is heavily computational based. Python paradigm is procedural, so you can write it from top to bottom. It is also object oriented, if you're familiar with Java, which I hope you are. And it also has functional support. Don't ask me about functional because I've never really used it. All I know is that Haskell and Scheme, I think, are both functional languages, but I've never been in that world. I'm always more so stuck to procedural Python or object oriented Python, but mostly I stick to procedural. Object oriented, I'll leave for Java. It's also easy to pick up, which is kind of why I wanted to teach you Python rather than anything else. Because if you're at a hackathon with other individuals who don't know Python, I'm pretty confident that by the end of this course, you'll be able to write it in such a way that your colleagues and coworkers will be able to understand what you're trying to convey, especially if they have programming background, right? So there's no neat, insane tricks that I'm going to go over. There are some Pythonic kind of syntax sugars, people like to say, that will be hard to grasp, but most of the language is pretty easy to read. It's also multi-platform. It's supported on Windows, Unix, which is both Linux and Mac. And I just went over why to use Python. Okay, let's look at our first Python program that I wrote. And I kind of made it big for a reason, rather I kind of made it a little more intimidating for a reason, because I wanted to show you what is really happening and not happening. So first I created a class, I hope we're all familiar with classes, called comp_sci_student. Then I created a constant class property, which means it's not an instance property, it depends on the class. It doesn't depend on the instance, it's static, in other words, called program, which means computer science. So everybody who is of type comp_sci student has this program property attribute. And then we have in def under underscore init under underscore. What does that mean? So that is a constructor. That is what a constructor looks like in Python. It's a little weird, but things with two underscores typically in Python are reserved for the Python language. So you never really have to write anything with two underscores unless sometimes you're writing private variables. We pass a name, we pass an age, and we pass a role. And here we also pass this thing called self. If you're familiar with Java, you know the this dot. The self is effectively the same thing, except instead of this, we call it self. So here we assign instance property called self.name equals name, which is passed through the constructor. The age is whatever passed through the constructor, and role is whatever passed through the constructor. And then we have getters and the toString method. So if we want to get the person's instance name, we pass self because we're calling, anytime we're calling an instance method, we always need to pass self into the parameter. It's just a rule. And we return self.name. So if we look at the bottom, at the second last line, we say instructor equals comp sci student Mike Pressman 24 instructor. So what I'm doing is I am implicitly calling the init function where I pass Mike Pressman as my name, my age 24, and my role as an instructor. So now we have a class. We have initialized an instance of a class where we store it as an instructor with all those properties. See here, we don't have any types, so we don't have comp sci student instructor equals new comp sci student. That is because Python, again, as mentioned, is weakly typed, so we can skip out on all those kind of bloatware. And then we also call print instructor, which is strange because instructor is an object reference. We're referencing comp sci student. But as you can see, if you go look back to the underscore underscore string underscore underscore, when we call instructor, we're actually implicitly calling that method, which is the toString method equivalent from Java. So whenever we print instructor, instead of getting a memory address, which is typically what would happen, we return my name is self.name, which is Mike Pressman, and I am 24 years old, and I have the role of instructor. So skipping this class, let's continue and look on to something else we have. So forget the class scope. Let's look at the line 31. We have print, hello, welcome to the Python fundamentals, and then we have a name, which is in these weird brackets. I'll go over that later. And then we have print and a for loop. Again, I don't want you to get too lost into what's happening right now, because I do want you to pay attention. So don't worry about what's happening here. We will cover everything step by step as we continue. Also, I want to show you a little bit nicer, something simpler. So in Python, we could always, at the beginning of line 1, just write print and then print whatever. We don't need a main function. We don't need any class. We could just write we could procedurally write at the beginning print hello world, and it would print out. But here I've added this kind of Python integrated function called if double underscore name double underscore equals main, then print inside main. So whenever a project sees this, it will execute whatever is under that scope. So it will first execute line 3 to 4, and then it'll execute line 1. If 3 to 4 didn't exist, we would just be printing outside main. But here we are printing inside main and then outside main in that order. Okay, now let's get into more nitty and gritty stuff, and let's be more specific on what's happening. So the types. In Python, we have pretty much 3 basic primitive types. We have integer, float, and string. Integer is like anything. It's just hold a value of integer. We have a float, which will hold a decimal base point. And we have a string, which will hold a string value. So we have 500, 500.0, and then a string of 500. So here we encapsulate this in double quotes, but that's not necessary. We could also do it in single quotes. Python will accept double or single quotes for strings, which may be strange for you because some of you are coming from languages where char is where a character is the only thing encapsulated in single quotes. But in this case, we can actually put a string here. So there's no char really. how do we figure out the type that we're using? So let's code this. So I decided, right, we have some int. Remember, there's no classifier. There's no, int some int equals 500. Just it will interpret that this is an integer value equals 500. We have some float 500.0 and some string. Then what I did was I called this Python function, which is called type. I called type on each of these respectively, and got this. So when we printed type of some int, it gave us an int. We print type of some float, it gives us a float. Print type of some string, it'll give us a string, which is really nice because sometimes we may get lost as to the types that we were using. In this case, we can always check. So if you're ever debugging, and you forget what type something is, or rather you're getting data from some external source and you don't know what type is coming in, just check quickly, print it out. We can also parse one type to another. So I'm using the same example as earlier. And remember, some int is an integer value. But here, what I'm going to do is I'm going to recast, or rather parse over some int as a string. So I'm going to say, instead of having string in two brackets, string will encapsulate the sum int. So sum int equals string of sum int. And I'll do the same thing for float. I'm going to say some float equals the int of some float, which will be interesting. And now we have some string, which will be, remember the string value, will be a float of some string. So now what do we get? So now we have some int, we're calling the type again to check what types we have. So now our int has changed from int into a string. So now it will be a string, it will be encapsulated in double quotes. Our float value will be an integer. So what that will mean was it will truncate everything before, it will truncate everything after the decimal point. And our float, and our string rather, which was encapsulated in double quotes 500.0 will now be a float of 500.0. So now we can use those types and those objects in different ways depending on what we want to achieve. So yeah, I hope we got pretty much simple understanding of the different types. The basic primitive types, which are int, float, and string. Those are really the only ones I really want to cover right now before moving on to this. Now for data structures. So well, I want to talk about dictionaries, lists, and sets. So a dictionary is a Java equivalent to a hash map, where you have a key and a value. So some key will store some value. You have a list, which is just another way of saying an array. So you have an array of values. You have an array of values of integers. And then you have sets. Sets are pretty much the same thing as lists, except they only hold unique elements. So if you have two of the same elements in a set, only one of them will be stored. And I'll go over that more detail. So first things first, we're going to have a dictionary. So I kind of put it under these, this print line, and I'm saying dictionary, I'm going to call the variable dict equals, has these curly braces, which will symbolically symbolize that we're making a dictionary object. The integer value, the key value will be an int of 1, which will store the value of string 1. Now we're going to go to the next element in the dictionary. We're going to say we're going to have a key of string that has stores 2, and it was value will store the integer 2. Now this is interesting because we have keys of different types. So our first key is an integer, and our second key is a string. This means that Python gives us more flexibility than Java. Java, for a hash map, is a generic type that will be strict on the type. So in Java, if you make a hash map of integer to integer, the keys can only be integers. But in Python, the keys can be integers, can be strings, can be floats, can be whatever the heck you want it to be, because of the way that the dictionary object works, which is closely related to the way the hash map object works. And if you've taken any algorithms and data structures class, you'll know the way hash maps work is they store keys as a unique element. So when you have a lookup of the key, it'll find exactly its pair value. Later on, right after we just print dictionary.get1. So we're getting the value of key 1. I'll show you the output and we'll look back at that later. A list is a little bit easier to convey. A list, again, is just like an array, and there is no declaration of its type. We're just going to make a variable called list, and we're going to encapsulate it in two square brackets. So we're going to have a list that has first, at index 0 has 1, then it has the value of string 2, and then it has float 3. Again, list isn't strict on types. You can have whatever types you want. You can mix and match. This comes at an expense of speed, the way Python executes, but it nevertheless benefits you because you have more flexibility. So we're going to print list after. We're going to print the first element, the 0th element, which will just be 1. And then we're going to print the len of list because I want to show you the special function called len. I also, before going on to subscript, let's skip that for just a second. Let's go into the set type. So we're going to make a set, and our set is also going to be denoted by the fact that we have curly braces. The only difference, the difference that we have with the curly braces and set in dictionary is the fact that set doesn't have a value pair, right? There's no key values, they're just one value. So in the set, we're going to store 1, 2, 3, 3. Remember how I said set values are unique. So when we print some set, let's look at the set, the last output, we're only going to get 1, 2, 3. It truncated the last 3 because you can only have unique values. So it's going to get rid of one of the 3s. Now this is a useful data structure if you ever need to store unique values. And a lot of the times you'll have many interview problems where this is required, or rather this type of data structure will help you. Let's jump back up. Let's look at dictionary. Let's look at the output of dictionary from the right hand. So when we call dict.get, we're calling actually get the value of key where the key is 1, which will return the string 1. I know it doesn't encapsulate it in quotes, but this is if we were to do type, this would return a string. Then we have list. The first thing we did in list is after creating it, of course, is we printed it. When we printed it, we saw 1, the integer value 1, then we saw the string 2, then we saw the float 3, which is exactly what we wanted. It stored everything the way we wanted with different types, mix and match, and it didn't convert anything or give us a headache. Then we did print list index of 0, which will just print us the first index, rather the 0th index, which is 1. These are one and the same. And then we print len of list, which is the length of the list, which is 3. We have 3 elements in this list. We have 1, so the string 2, and the float 3. We have 3 elements. It'll return the length, which is 3. Now I want to look at subscripting. So for subscripting, I created some other list. I called it that. And I have values 1, 2, 3, 4, 5, 6. Now what I'm going to do is I'm going to print this some other list, and I'm going to index from the second element up to and not including the length of that list. So the length of this list is 6. We have 1, 2, 3, 4, 5, 6 elements. And we're going to print from the second index, remember array start at 0 all the way to the end. But the end isn't included. So we have these 2 kind of colons to indicate that we're starting from 2, but not including the length, which is okay because the length, and again, remember arrays are offset by 0 and the length. So when we call 2, we get 0, 1, 2, which is the third element, which is the value 3. So we get 3, 4, 5, 6. And the length is 6, which doesn't call it 6 because it doesn't include len, it includes the -1. So it'll print out 3, 4, 5, 6. Hopefully that makes sense. If not, I'll come back to that a little bit later. So now that we have looked at that, let's look at iterating a dictionary. So I've created a new dictionary. I've said that the keys are going to be 1, 2, and 3, and respectively the values are A, B, C, the string. So what I'm going to do is I'm going to call a for loop, and I'm going to say for key in some dict. So this key was a chosen decision. You could call this whatever you want. You could say for A in some dict, or for C, or for XYZ in some dict. But I like key because it's nice and explicit for the fact that I'm iterating over the keys of the dictionary. And what I'm doing here is I'm now doing for key in some dict print the string value of the key because they're integers. So I want to print out, we can only print strings. I'm going to print the string value. I'm going to have a space in between, and I'm going to grab the value of some dict respectively to the key. So what that's going to look like is like this. So I'm going again from the beginning. I'm going to go for key and some dict, print the string value of the key, which is an integer. So I'm going to print a string value, which is 1. Then I'm going to have a space in between, which is a little space, and I'm going to print some dict indexed of key. So I'm going to get some dict of 1, which is going to look up. It's the same thing as the .get method as we looked at in the last slide. We looked at the last slide, we have print dict.get1, which will get the key with the value 1. But here, we are just doing the same thing by indexing it, which is looking at grabbing the values of some dict of 1, which will have A, some dict of 2, which will have B, and some dict of 3, which will have C. Again, we're passing the dynamic value of key because key gets iterated each time through this loop. Another way to iterate through a dictionary is through doing it through a tuple. So we could call some dict, again, the some dict I didn't change, kept it the same for simplicity's sake, and we could call .items on it. .items will return a tuple. A tuple is just a pair or just a collection of values. You can have a 2 tuple, a 3 tuple. They're just a collection of values in circle brackets. So here I'm going to do for key comma value because I know that my tuple is going to be a 2 tuple. It's going to only have 2 values. In some dict.items, print the string of the key plus the value. So instead of indexing the key to get the value, I'm just going to return the tuple on each iteration and print their key and value. Again, the key and value are chosen names that I've given. You do not need to call them key and value. You can do for A, comma B, or for cat, comma dog, and it will be the same thing as long as you're calling print string of cat space plus dog. Again, respectively, I hope you all understand. And this output is the same. The output looks exactly the same, and at the end of the day, this is all design decision based on yourself. Let's look at Boolean values. Pretty simple. We're looking at, we have going to assign the variable t to true, f to false. There's nothing special there. But I also want to look at other values that we assign and may parse later. Remember, we're going to parse them with the bool call. So I'm going to have t2 equals 0. I'm going to have t3 equals the string hey, and t4 equals the empty string. So when we call print the Boolean value of 0, it gives us false. So 0 is a falsy value. When we call a Boolean value of a string that is not empty, which in this case I just wrote hey, is going to return true. But if I call the Boolean value of t4, which is an empty string, it'll have false. So the main idea here is I don't want you to remember every single rule of how Booleans get parsed between what values the variable is storing. But I do want you to understand that its behavior is kind of, not to say random, but it's kind of stochastic in the fact that sometimes you may not understand. So be careful whenever you're doing this. Now functions. Now this is going to be a lot to cover. There's going to be a lot to swallow all at once, so don't do that. But the information we're going to convey is basically going to be the same. So for the first function, we're going to call it with the def keyword, which is just short form for define. We're going to say def func underscore 1 brackets. In Python, functions are usually separated with underscores, depending in the names. Rather, where in other languages you have camel case, here we're using underscores. I should have mentioned that earlier, but that's a pattern we're going to see a lot in Python, that it uses a lot more underscores than anything else. So in the first function, we're just going to print 1. That's simple enough. It doesn't have any types. It doesn't do anything special, but it's just going to print out 1. Now we're going to define a function called func underscore 1 underscore alt, which is just short for alternative. And here, its return type is I have as none. So what I've done after this function, before I've added the 2 colon, is I've done an arrow, and I've said that its return type is none. This isn't necessary. This isn't needed, but this looks nice sometimes. And you may see may see other people using this, you may see other people not, which is why I kind of wanted to introduce you to this, because sometimes you'll read Python code which will look like this, and I don't want you to go, huh? What was that? I never learned that. So this is the same thing. It returns none because it, again, returns nothing. All it does is it behaves like a void function. It just prints one. So those were functions with empty parameters. Now we're going to look at functions with parameters and multiple. Now we have func underscore 2, which takes in 3 parameters called name, age, and school with no types. And we're just going to print out name, space, string of age, space, school. Nothing special like here. Now we have function 2 alt, which has name, colon, string, comma, age, colon, int, comma, school, colon, string. Now I've added types. So now I'm kind of enforcing the fact that the first parameter that we're passing, which will be defined as name, has to take in a string. The second parameter has to take in an int. The third parameter has to take in a string. And it's going to return none. I don't like this. I think this goes against the grain of what Python really is at the end of the day, which is simplicity. But this exists, and this is a decision you have to make for yourself, whether you want it to look like this or not. But be aware that it exists. So you can have types looking like this. I'm not sure if they'll be actually enforced all the time, but be aware that this exists. Again, this function doesn't do anything, returns none, it's void, so I'm just going to print something out. The next function we're going to look at, function 3, takes one parameter and returns a value. So we're going to take an age, we're just going to return age plus 1. Nothing crazy there. We're going to have the func3 alt, which takes an age with the types again as int, and it's going to have now return type with the arrow as int. Now we're not returning none. Now because we have the return keyword in the function, it's returning some value. And this value here is going to be an integer. Again, be careful with what you're returning and what your program may have accidentally returned, but here the idea is the same as we earlier looked at, and that's the fact that we've kind of enforced types here. I don't like this. I don't recommend it, but that's a decision to make for yourself. The third example, or rather fourth, function underscore 4 is to emphasize that all types can be passed, right? The first three, I just only looked at string, int, and float, but we can also pass a list. Remember what a list was? The list is just another word for an array with those square brackets. So here I'm passing a list into my function, which I'm calling SumList, and I'm returning an int. So what I'm going to return is the first element in that array. So I'm just subscripting SumList at index 0, which is going to be assumed as an integer because I've written in my function returning an int. So I'm going to hope that my sum list at that index returns an integer. And this kind of comes back to the problem with why I don't recommend using this, because remember we looked at arrays that have mix and match types. We can have an integer, we can have a float, we can have a string all in one same array, which can get kind of messy. If you're enforcing and you're showing other programmers that it is returning an int no matter what, you better make sure that the first 0th element of that list has an int in there. You better be 100% confident, or else you're lying. Next, we're just calling these functions. So func underscore 1 just prints 1, so we have 1 here. Func underscore 2, which has my multiple parameters, is Mike 24 York, prints Mike 24 York, just as we intended. Then we have function underscore 4, which is going to return a value. So I can call print on the func4, but what I'm doing here is I'm storing the return value and calling it ret underscore value equals func4, where I pass in a list with 2 elements only. That's just this design decision I made for simplicity, 1 and 2, and it's going to return, remember this function returned the 0th element, which is just going to be 1, and I'm going to print the return value, which is 1. So now we have that value in memory as ret underscore value. And again, I didn't have to store this. I could have just called print as a wrapper on top of func underscore 4. Functions continued. So remember we talked about tuples. Now here I want to show you. So tuple, we can have 2 tuple, 3 tuple, all the way up to kth tuple. K is any element of an integer. And we're going to have a function called return mult, which I just simplified for multiple, which returns a tuple. Here I made this obvious, even though I don't agree with it, but I just wanted to show you that it returns a tuple. and I'm going to return in brackets 101, 102, and 103. So here I'm returning multiple values, which is a nice benefit that Python provides. I don't think a lot of languages give you this flexibility of returning multiple values at once. A tuple is not mutable, which means you cannot change the values in it after it has been created. That is something I don't really want to get into right now because I don't think it's necessary for your knowledge in a hackathon. So below that, I call return underscore mult, which returns the values of the tuple, and what I do is I unpack the tuple. I say, okay, val1, val2, and val3 respectively are going to be the return values of the function that I made called return multiple. And then when I print val underscore val1, I'm going to get 101 because that's the first element that I've unpacked, which is the first element that is returned. Now I want to talk about default and non-default parameter types. So we have a function called func5, which has three parameters, a, b, and name. And name, I've given a default parameter value called Mike. So I've said name equals Mike. And my function does nothing special. All it does is it prints name, and name calculated that a plus b equals the string value of a plus b. Now when I call function 5, what I can do is I can call function 5 as func underscore 5 1 comma 1 with only two parameters, and it'll work, and it'll return Mike calculated a plus b plus string of a plus b. Or I can pass an alternative value to overwrite the default value. So instead of Mike, it's going to print Michael calculated that. So if you have a different name in here, you're going to have that overwrite the value here. So this is nice if you have some template function where you're going to assume maybe sometimes a name won't be passed in. Maybe sometimes we'll just have to use a default name. Last part of the functions is multiple arguments. Now this syntax looks kind of funny. If we look at the parameters, we have asterisk args and comma asterisk two asterisk keywords. This stands for arguments, and this stands for keyword arguments. So let's skip what's happening inside the function for now and just look at the very last line where we call the function. We're going to call args underscore function, and I'm going to call a plethora of values. I'm calling 99, 98, 97, all the way to 95, even though our parameters only accept, our function is only accepting two parameters, which are these two strange parameters never seen called args and quars. And then we're going to call, remember with the default arguments, these are called named parameters, where I have a equals a, the string value, b equals b, and c equals c. So the reason that's order matters. So the fact that I made the parameters with no equal sign on the left side for the ones with the equal side, rather the default parameters on the right side, is important. So in this function, you'll see the importance later. In this function, we're going to go for each in args. So we're going to iterate for args, because args, what args really is it returns a list of the values that we pass in. And we're going to print out all the values in args, which, as you can see in the bottom, just prints out 99, 98, 97. Again, it prints out everything we passed. We could have passed as many values as we wanted. Then we have our second for loop, which we iterate is as quargs actually passes a dictionary. So what we're going to do is we're going to call the values on the dictionary, and we're going to say for each in quargs.values of the values in the dictionary, print each. So we're going to be printing A, B, and C. We're going to be skipping this actual name. We could do for the items. We could call the items as we did before and get the key and the value. But here we're just calling dot values. And we're getting A, B, and C. As you can see in the bottom right hand corner. So this is nice because you can pass as many parameters as you want with default names or non-default names. Now let's look at different loops and statements. There's nothing really special here that you may have not seen. We have some function. Let's look at the first if statement. We have some function 6, which takes some input, and we're just going to check if some input equals A, print A. Else if, which is this weird elif. This is how we call else if some input equals B, print B. Else if brackets some input equals C, print C. Now, the reason I put brackets here is to emphasize the fact that in Python, you don't need brackets around the whole conditional statement. In Java, you would need if brackets some input equals a bracket, but in Python, you don't need that. Remember, the two equal signs is a comparison operator and not an assignment operator. So we have these if statement, a bunch of else ifs, and then we have an else as a default case, saying that, okay, if none of the values that we pass are any of the checks, just print default. Now we also have a while loop, which we also pass some value. We say while x is less than, while the value we pass is less than 10, just print it out and iterate it. Nothing special here. Again, while loop does not need to be encapsulated in brackets. And I do want to emphasize that the space between the while loop, same thing for if statement goes, the space between the while loop and inside the scope of the while loop needs to be 4 spaces or a tab. So you need to make sure you're tabbed in. As well as for function, every time you go inside another level of scope, you need to tab in. Otherwise, you're going to get a bunch of linting errors from the Python interpreter. Lastly, let's look at a for loop. We looked at a lot of these earlier. So here we're going to pass in a function 8 a value. We're going to pass 10. And what I'm going to say is for I in range of x. For I in range of x, which is just looking like encapsulated in x, we're going to print out all the values from 0. This I by default starts at 0, and it's going to go up to but not including x. So range will iterate through all the elements up to and not including x. So this is like a Java for loop where you have int I equals 0 till I is less than x dot length I plus plus. But this is just a nice, easier way to do this because range handles all those internals for us. As you can see here, we pass function 8 passes 10, then it'll print 0, 1, 2, 3, all the way up to 9. Remember, it won't include 10 because I will start at 0 by default. And now we're going to have our own custom little loop. So we've changed the parameters inside range, and I'm going to say for I in range 2, comma x, comma 1. So what this means is, respectively by the parameters that are organized, I'm going to start at the value of 2. So when here it started at the first for loop, it started at 0. But here I'm going to start at 2, and I'm going to go all the way up to and not including 10, which is the value passed as x, and I'm going to iterate by 1. So this is like saying I plus plus, but I could have I plus equals 2, I plus equals 3 by just putting 3 if I want to iterate by 3s, or iterate by 4s, or by 5s. Same idea here. Instead of starting at 0, we start at 2, 3, all the way up to 9. So that's simple enough. Again, to reiterate, we start at 2, go up to, but not including 10, and we iterate each I element. Every time we finish, the next value of I will be plus 1. We could have 2 here, which would mean I would be plus 2, but we don't do that, as my example just shows plus 1. Here I have more loop statements continued, where I pass some object. In this case, the object is going to be a list, an array, with values 1, 2, 3, 4, and I'm going to print each element in the object, which is just going to be 1, 2, 3, 4, respectively, like that. Now I also call func9 on a string. So I'm going to do for each in some object. So when I do this kind of for loop, I'm secretly internally indexing all the elements. Strings are actually indexable. So I can do string of 0, string of 1, string of 2. So here, instead of that, I'm doing iteration of all the elements of a string. So here, as you can see, I have a space string. So I'm printing all the elements of the string like that sequentially. Now I'm going to have another for loop, which I think is really important to learn because sometimes we need the index value. Remember we had this value, which is for each in some object, which looks at the value at the index. But here when we add the enumerate keyword, what really happens is we pass I comma element and enumerate some object. So I am going to have is the index value, and element is going to be the value at that index. To really hone this home, what I'm going to do is I'm going to say print string of element is at index string of I. So again, I'm doing for I comma element and enumerate some object. Some object here is going to be a list that stores strings ABC, and I'm going to do I element. So the ith value will be the index, which will be 0, 1, 2, and the element will be A, B, C. Hopefully that makes sense to everybody. So this is just like a typical for loop that you may be used to, which is just for int I equals 0, I is less than some object.length, I plus plus, and let's print out the I value as well as the element I at the I value. Let's check time here. Awesome. Let's look at some other keywords. So we have a list which has 4 elements. It's just a simple array, and I'm going to say if one in some list. So I'm going to check, is the value 1 in some list? It's going to return true for some. So is 1 in some list? Yeah, of course. We have it as the first element. We've got to be careful of this because this is an O to the N operation, which means that if you nest these, you can get really expensive in terms of algorithmic complexity, but I don't want to get into that. But understand that a lot of the internal functions do come at a cost that you have to be aware of. Next, I have a dictionary where I have the keys 1, 2, 3, 2, and 3, and I have their values as A, B, C. I'm going to check if 1, 2, 3 in some dictionary. Then it works as well. We can also look up keys, which is the same idea. It's going to be O to the N. But we can only look up keys, not values. So we can't check if a value is in there with this method, unfortunately. For values, we're going to have to iterate. Lastly, for sets, remember sets we talked about have unique values. If 3 in some set, then do that. And as we can see in our bottom right output, this is all true. So these all work. All these are statement words. So this in keyword will again look for elements in data structures instead of you having to write your own loop and check if it's actually in there. There's this keyword called pass. So sometimes you may be writing a program and you may have a actual function that you want to write in the future, and you've written the protocol for that function, but you're not finished it. And Python will throw you errors if you try to run your program. So instead of kind of dealing with these errors, just write pass and say, okay, I'll come back to this later, but know that this function prototype that I've written, which will be handled later and implemented later, will come out another time. This is just an easy way to avoid bugs that Python will say, like, oh, you're missing code in here, or you've indented for some reason. The same thing is for our last example. Remember, we have for I in range. Remember, the range does iterates through elements. So we're going to start from 1 up to 100 and iterate by 2 each time. So I'm going to check if I is modulus 2 equals 0, return break. So what break's going to do is it's going to exit the loop. It's not going to exit the if, it's going to exit the entire loop. Sorry. So yeah, as you can see, this break keyword will check whether it will exit the loop, and in this case, it does, I believe. And if it doesn't, then it will continue the loop. It'll just go to the next element. This continue keyword will just go and be, okay, it's we're going to print I, let's go up to the next. This continue is kind of extra in this example. It's not really necessary since the loop will continue regardless as long as the condition is satisfied. I don't really like talking about methods a lot that Python has because there's just too many in every language, and memorizing them is, in my opinion, nonsense. I think you should use what you need because I'm a big proponent of if you don't use it, you lose it, and if you don't use it, you really don't need it. So I'm not going to force you to remember all these methods, but there are some things that I think you should know. So these are just examples. So we're going to have a string called hello world. We're going to print a len of string. We talked about that earlier, so I wanted to bring it up again. This will print the len of the element, the len of the entire string, including the space in between. Now we're going to have another object we're going to call another underscore string. When we say hello, but we're going to delimit it with these backslashes. Nextly, we're going to say split apart equals split the backslash. Now here, I want to split my string by their backslash, but here I have 2 backslashes, which is a question you may have, like, why do you have 2 backslashes when there's only 1 in the string? Well, the reason is because backslashes are typically escape characters, so in order to specify that you're looking for 1 backslash, you actually need 2. If you need more assurance to what I mean by that, search up escape characters, right? You'll look up things like /tab, which will look for tabs. So instead of here looking up we're looking actually for the literal one slash. Kind of confusing at first. Don't be too intimidated. Uh, and we're going to split by backslashes. And what it's going to return is it's going to return an array of elements delimited by their backslashes. So let's look at the output quickly. We have the len of hello world, which is 11, and now we've delimited our string by backslashes, returns hello in string format into a list. We can also do the same thing backwards. So now that we have this data structure called split apart, which is a list, and it is split by different, it was split by slashes, we're going to join the elements in this list by using the .join call on this string literal dash on split apart. So we're going to join now this hello by dashes. So now we're printing hello in dash form. There's also, hopefully that's obvious. Not, please raise your hand. And also there's the last method I want to talk about, which is instance. Just pretty much check if something is an instance of something else. This is good for objects, just like the example I did with type. You know, if string is type, print out the string. But this is better for conditionals, right? You want to check if string is of instance string. So we press a string literal, check, and check is it an instance of a string, which it is in this case. Now I want to talk about pass by object reference. So a lot of languages handle passing arguments differently. Python does it by pass by object reference, which is just a fancy way of saying pass by value. If you understand how Java passes objects and primitives into functions, this is the same thing. They just call it differently because of the way the Python works internally. If you want, do some Googling on your own time. If not, just understand that it behaves like Java, and the next examples will hopefully clear that up. So we have some function where we've taken a list, and we're going to change the 0th element of that list to 100. So we have a list. Now we're going to declare a list. We're going to say it's going to hold values 1, 2, 3. Now we're going to pass this list into this function. I'm going to print some list. What do you think will happen? Remember, a list is an object type, which is in kind of an array, we'll think of it, and we're indexing this 0 and changing it to 100. So what will happen is now our list will look like this. Even though we haven't returned anything from this function, we're passing by a value of the memory address, which changes the reference at that element. So 100 to 3. If we were to reassign list into another list, then our sum list would stay the same. We can't reassign this object to something else, but we can change the values internally. So now we have 100 to 3. And this is nice because we didn't have to return anything. We just did it all inside the function. Now we have, I want to emphasize the next point where we have another list equals 200, 300, 400. And we have a function which takes in a list and it reassigns that list to 2000, 3000, 4000. So we call that, print it, and we see that nothing has changed. Reassignment will not happen. If we changed individual values within there, they would change on the original another list. They will reassignment on the entire object will not happen. Remember, we're referencing and passing by memory address as value. Cool. We've kind of gotten the crux and kind of the basics of the topics. I know we did that kind of fast, which is okay. The slides will be available later, or maybe I think they're available now, or you can always go back to the recording. There's nothing confusing that we talked about. I hope nothing was too hard, and it was to kind of get you comfortable. I don't want you to memorize anything, or rather, I don't want you to memorize everything. Hopefully, you take something away. But I want you to understand the simplicity of Python is within the language itself. There's nothing crazy. There's nothing quirky. Everything you learn and everything that you will forget, just like how I forget all the time, can be Googleable quickly as long as you understand what exists. Remember, websites like Stack Overflow and other forums that help you exist because programmers weren't meant to be a thesaurus of knowledge, right? You can't remember everything. It's just too much. So what I want you to take away is understand what exists, and so you can look it up later and get a more concrete understanding later. let's look at some more advanced topics that you may kind of look at in the future. So let's look at this. Look at this for loop. So I'm not going to put it in a function. I have it here. So I've created some list called odd list, and I'm going to iterate all the elements from 0 up to 200, but not inclusive because of this range. And I'm going to check if I modulus 2 does not equal 0, so if it's not an even number, add this element to the list. So we're going to call dot append. We're going to append this list. And then we're going to print out our odd list. So after we've completed this whole loop, we're going to print it out. That is a pretty big for loop. Doesn't really do anything interesting, but it takes up 1, 2, 3, 4, 5. This for loop does the exact same thing. It takes 2 lines. So whether you want to count the print as a line or not. So here, what I'm doing is called a list comprehension. So what I'm doing here is I'm saying so a list comprehension kind of works from bottom to top recursively. So I'm calling the at right here is the append. So I'm saying for I in range of 200, which is the top, if I modulus 2 does not equal 0. This may be hard to kind of like swallow all at once. It really was for me at first. I had to look at it a couple of times. But this does the exact same thing as the left-hand side. Don't memorize this. Don't try to understand this all at once, but visualize and get an understanding that this exists. And this is here for simplicity's sake if you really want to be fancy. So if you ever read anyone else's code and it looks like this, you're not too confused. Let's look at error handling. So errors will occur. They're good and bad errors, but we always have to make sure we handle them in some way, shape, or form. So we have in other languages try and catch, and here we have try and accept. So we're going to try. We're going to try something, but here my try, I'm just going to raise an exception, which means I'm throwing a new exception essentially. I'm going to say raise exception and say some error has occurred. And if we're going to have in our accept case, if an exception has occurred, print that exception. So what will happen here is some error has occurred because inside my try block, I have explicitly raised an exception, which usually doesn't happen, but here I did that. For example, I'm going to say if exception happens, catch this exception. So this is the accept block is catching these exception as E, which means that we are storing whatever the exception returns, which is a string, as E, and we're going to print it out. We need to catch exceptions, or else our program will fail. Our next example, which I'm going to look at below us, is going to have more elements to it. Now we have try, accept, else, and finally. So try and accept. So same idea as before, some error has occurred. But what if some error has not occurred? We're going to, in our try block, we can add an else clause, which says, okay, no error has occurred. So if you ever want to check if no error has occurred, you can always print something out, or you can continue from this block with inside here. And then we're going to have a finally case, which gets thrown regardless. So if you have an exception, this gets thrown. And if you don't have an exception, this also gets, rather thrown is the wrong word, this gets called. So what's going to happen is we're going to say some error has occurred, and we're going to say print this regardless. So even if we didn't have an error here, even if I didn't raise the exception in the try block, we're still have print. We will instead, our output will look like no error, and then print this regardless. So the finally will happen in any case. The else will only happen if we didn't have an error. Let's look at the last figure, where we have x equals 500 and I equals 0, just two simple integer values. And we're going to say try x divided by I. Well, there's an obvious problem here. We have division by 0. So here we're going to do accept 0 division error as E, print the error, and we're going to say finally, hopefully we didn't get division by 0. Remember, finally will be called in any case. So what I want to emphasize here is 0 division error. Now, how do you know to call 0 division error? How do you know that it'll potentially be called? Well, that just involves a lot of experience in Googling. So if you have a try block which will handle something, you have to really consider what could go wrong. Here I know 0 division error could go wrong. So what I will do is I will go on Google and I'll write Python division by 0 exception, and it'll give me a list of recommended exceptions that I could catch that will happen. Or what I could do instead to figure out what error would happen is I could purposely make my program crash. So I could write 500 divided by 0. That's it. That's all I can make my program do. And then I would see in the stack trace that it would say, oops, we had an exception, 0 division error, and I would know exactly what to catch next time. So in the future, I would know exactly that I want to write 0 division error as E. Our output is division by 0. That's what 0 division error by default returns as E. And then we have our finally clause, which will get called and does get called regardless. Decorators, I kind of want to save this for next time. We're kind of running short on time and it's too much, too convoluted to cover now. But maybe if we have time, we'll come back to this. For now, we're not going to cover this. It's too much. Context managers. So context managers are nice for handling resources. So let's say I have a file name called grades.txt and I want to write to that file. So I'm going to say is the context manager is called with this with keyword. I'm going to say with open file name w as file. And what I'm going to do is I've opened this file and I've opened it in write mode. That's what the W stands for. You can look at that later. And I'm going to say for line and file. So file will return a list where I'm going to look at each element in the list. I'm going to print out the lines in the file. So I'm just going to read it, do it. I maybe should have called this with WR instead in here, which means read write or write read. But here I wrote it as write. But it doesn't matter in this case, I don't think. But here we're going to just open it, read each line in the file, and once we've exit this scope, so after the for loop is finished, we exit the scope of the with clause, the file will close on itself. The context manager means that the resources of the file, and rather resources of anything that you're opening in context, will close and handle cleanup by itself. So here you don't have to worry about file.close because the context manager will handle this for you. Here's an example of a database connection context manager that is customly written. So here we have a MongoDB database, which is a typical database used in a lot of different projects. And here they wrote it as a class. So they have a constructor, which passes a host name, a port, and a connection. And then they have this underscores in enter and exit. Remember, underscores, double underscores at the beginning and back are reserved for Python functions that do something special. So here I'm going to say once we enter, we're going to create a new instance. So self.connection is going to be a new instance of a Mongo client, which is just another class that gets called somewhere else. We pass the host name and port, and we return that instance. We're going to return self, which is an instance of this class. And then once we exit, we're going to call self.connection.close. So I don't want you to really stress on the enter function. Just look at exit. We call self, execution type, execution value, traceback. That doesn't matter, right? Those implementations were written by the MongoDB team. But what I want you to emphasize is the fact that you can write your own context managers, where here at the bottom, we call this context manager with the with keyword, pass our hostname and port. Remember, we're making a new instance of the context manager as Mongo, doing whatever we have to do inside here. I don't think it doesn't matter for us right now. And once this exits, this exit function will be called implicitly. And respectively, once this enters, this enter function will be called implicitly. So once with gets called, enter gets called immediately, then this line, then collection, then data, then print. And then exit gets called implicitly as well. So there's no cleanup we have to do. This context manager will handle this for us. And this is nice because this lets us write less code, because if we're calling and opening databases many times, we don't have to write enter and close, enter and close, enter and close. We just write this one context manager that will handle this for us every time. I want to talk about Lambda functions as well. Lambda functions are interesting. They're short little functions that can be called anonymously, and they're used with this keyword Lambda. So I'm going to store some small function as Lambda x, and its return value is going to be x times 2. So when I call some small function, I'm going to pass the value 2, and its return value will be 2, or rather x, 2 in this case, times 2, which would be 4. You can see that here. So we call some small function 2 lambda 2 times 2. But we have another example. We don't have a lambda function, right? We have some other small function x, or return to x times 2. The lambda function and the function that we're used to looking at from other examples with the def keyword are the exact same thing. There's nothing special. There's nothing crazy about them. The only craziness is that they're one line. They're simple, they're easy to look at, and they're concise. Again, that's this design decision that you have to make for yourself. The output is the same. Lambda functions continued. We can also call lambda function without storing anything. So earlier we had some small function equals lambda. Here we're just going to call print on lambda, the same exact function we wrote earlier. But we're going to immediately pass a value. So when we immediately pass a value, we're going to immediately get the return value. So here we'll get 4 instantly. We can also pass a lambda function to a function. So we have some function, as we define, we have x, y, and lambda passed. So, and then what we're going to do is we're going to return, the callback of lambda pass. So what I'm going to do is I'm going to take these two x and y values, pass them to the lambda, and the lambda gets executed. Maybe a little confusing, but let's look at an example here. Return value equals some function, that's a defined function, but we pass 2 and 3, lambda, x comma y, x colon x plus y. What do you think happens here? Pretty sure you know. We pass 2 and 3 into some function. We pass our lambda function, which is this entire block that starts with lambda all the way to the end, and then we return a call on that lambda function with those 2 parameters. The lambda function takes in 2 parameters. So what we'll return is 5. So here, instead of having the function define the functionality itself, we can have the lambda function define its functionality. Now, why is that useful? Why would I ever want to pass a lambda function? So let's say you have sometimes short functions which you don't know the behavior of. You're not sure. Sometimes it'll multiply something, maybe it'll divide, maybe it'll return something erratic or crazy, but you know that each time it'll only take 1 parameter. Instead of defining different large functions with the def keyword, we can just create def some function, 1 parameter, and lambda pass, and just call the lambda on that 1 function, or on that 1 parameter, and let that lambda handle its functionality. So lambda is good for handling external functionality where we sometimes don't know, and sometimes don't want to define big functions for it. That's another design decision you gotta make for yourself. I think it looks nice. Sometimes it can be confusing because you're calling function is calling another function which returns a value back. You just have to look at the order of operations. Right? Some function is called, then we're calling the return value of lambda passed, which returns 5 and returns 5 back up. So 5 is the actually almost done. Let's look at classes. We just want to look at simple classes that can get really confusing, but I just want to look at a simple example. So we have class student, which is the keyword class, and we're going to have a class property at the top, which means it's on an instance property, which means it doesn't matter on the instance of the value, it matters on the class object. The class as a blueprint as itself. And then we're going to initialize that counter as 0. We're also going to have a constructor defined within it, and we're going to pass self, which is necessary for anything that anything that handles instances. I'm going to pass student. So now, usually you'd be used to seeing, student name at the top, and then redefining this dot student name and student name. You don't need to do that here. Here, you can actually initially implement instance properties inside the constructor. So you don't need to store student name anywhere else. You can just initialize it in here, and it will be remembered by the class, by the instance. Also in this constructor, we call our static property, which is our class property, by calling the object student.id counter and incrementing it by 1. So each time we create a new student, our ID counter will go up by 1. So this is a nice way to keep track of our students that are coming. Lastly, we have the getter function, which passes self, which is needed for every time we call an instance method. It just returns self.student.
we're just getting back to the student name. As you can see at the bottom, it's pretty simple. We call S, assign it as a student, and you can see to the student Mike, print s.student name, or s.get name, returns my name, of course, Mike, and then we're going to call the ID counter on the class, which will be 1. If we create a new student, it would be 2, 3, 4, respectively. Cool. We're reaching the end. I'll make sure we have time for questions before we get to our allotted 1:30. These are the topics I want to talk about next time. I want to talk about imports, so importing different libraries. I want to talk about project structure, how a big project will look like, which will become way more evident when we look at a bigger class project. I want to look at classes more in depth because that was kind of lackluster for the sake of time and simplicity. Everything coming together is one, and of course Flask, which is our main motivation for even coming here in the first place. Cool. Let's look at a project that I made in, I don't know, 5-10 minutes as an example of what Python can really do in a short amount of time. So I'm going to only import one library. We're going to import requests. All request does is make HTTP requests. And what I'm going to do is I'm going to create a new object called response object, which stores none initially. Then using our try, I'm going to try to make a request to this website called JSON placeholder. JSON placeholder returns a dictionary. Remember dictionaries? A dictionary is the exact same thing as a dictionary object. So this website is nice if you ever want to practice getting requests from JSON objects, because mostly when you make API requests, so when websites like Uber or Shopify or Spotify or Tinder, when they have front end and back end systems, they usually split it up by front end team and back end team, where the front end team will make requests to the back end team, which will return a JSON dictionary, which is the exact same dictionary we looked at earlier, and then the front end team will handle that object accordingly. So rather than the front end team having to always coordinate with the back end team asking, hey, what type are you going to return? You know, what type is this return? What type is this return? They've agreed upon the fact that we're always going to return the dictionary. Now we know that we're just going to look at the keys and values of the dictionary to handle whatever we need to do on our end. We make a request to this website, which is returns a placeholder of some object. And then we're going to catch 2 exceptions. We're going to catch a missing schema exception, which is an exception that I got when making it, and comma. We're going to catch a generic exception. So if we don't catch a missing schema, but we get another type of exception, we'll still be safe. We're going to print out E. Else gets called if we don't have an exception. So now what we're going to do is we're going to reassign a response object on the request response that we made to the website. So I'm going to call request_made.json. So request typically returns either 200 or 404. 200 means the HTTP request was good, it was successful, and 400 means it was 404 means no good. Or there are different, of course, status codes, but generally 200 means everything is okay. So if everything was okay, we call the else block and we store the response object as JSON. After doing some digging and printing and debugging, I realized that the object that is returned by this website is a nested dictionary. So it returns a dictionary of dictionaries. So inside this dictionary, it returns a post ID, an ID, and a name. So what we have to do is we have to do a double for loop to look at the actual individual elements inside each dictionary item because they're nested. So we're looking inside. So when we iterate this dictionary of response object, we're not actually iterating the keys, we're iterating the object, we're iterating the dictionary that is stored inside. Kind of maybe confusing, but hopefully our next example make it clear. Then I create a list and I say post divisible by 0. So look at these post IDs. They get stored 1, 2, 3, 4, 5 sequentially. There's a bunch of them. What I'm going to do is I'm going to loop through each dictionary element in the response object. So I'm just going to loop through this one, and the second one, and the third one. But I don't want to look at the object as a dictionary itself. I want to look at the keys inside the object. So I'm going to loop through each element, which is each key in dictionary object. So I'm doing for dict object and response object, and then I'm going to look at inside each dict object, which is going to be a key. I'm going to check if that key, so if each equals post ID, so if that key is called post ID, and the value of the key, so looking inside that key, modulus 10 equals 0, which means if it's divisible by 0, then I'm going to append that individual post, that actual object, dictionary object, into our array. So our array will store dictionaries. It won't store primitive types like we're used to. It'll store dictionaries. The above code isn't excellent. It's O to the n squared time, which could be better. But again, I wrote this. It's just an example of how short code you need to do something. Lastly, I use an example of a context manager where I open a file called output_file.txt as write, and I say for each in post divisible by 10, so remember post divisible by 10 is an array of dictionaries, and I say for each dictionary inside that array, I'm going to write into the file the string value of that dictionary. I'm parsing that dictionary into a string, and that's what happens here. Our output file, once we run this code, we could actually go into the same directory where this project is stored, open this file, and we'll see a bunch of strings that are dictionaries of what we wanted, and it will be all posts that have IDs divisible by 10. Hopefully you go back and look at this again. We get a more deeper understanding. I think the only convoluted part is the double quote. But I think once you look at my examples, which are commented, where we have a dictionary, it all makes sense. These are some additional resources. If I wasn't of too much help, these are things that I used in my journey. First book I ever read was Automate the Boring Stuff. And I think my camera just died. That's okay, because we're almost done. Automate the boring stuff. Then a Flask mega tutorial, which is where I began my journey in writing backend websites. The documentation is always good, and this lab's website is a link to different libraries. That Python you can use with the import keyword and pip manager. Lastly, I just wanted to thank you for being patient. Hopefully it wasn't too much information. Hopefully it wasn't too dry. If you have any questions, please feel free to ask me. Yeah, thank you for your time.
Mike, I think someone's asking for another schedule for part 2.
Part 2 will most likely be within 2 to 3 weeks. I still have to talk to Mike, the head coordinator, but it will be really soon. I'll make sure to keep you guys up to date.
Okay. I'm sending your contact info here if ever wants to ask you or talk to you in private.
Absolutely.
And of course the PowerPoint, if ever it's on the top of the chat now.
Yeah.
Stay updated there. I suggest you guys save those links before we end the meeting.
Feel free to ask any question in chat. Yeah. Awesome.
You're all welcome.
Thank you for your patience, Jason.
Yeah, thanks everyone for joining in and sticking through the end. I just want to leave these links. If ever you guys want to know some updates regarding our upcoming events or have any questions, feel free to reach us on this one. I posted it in the chat. There you go.
I'm excited for part 2. Thank you, everybody.
Welcome.
Yes, and thank you to Alexis again for helping me coordinate all of that.
Our pleasure, though. All right, they're leaving. Yeah, we'll see you again, Mike, in part 2.
Also, take care, everybody.